All right, back here for
Question 3.
question 3 of exam 3. Let's go over this one. Describe the mechanisms for the inotropic, lusotropic, and chronotropic actions of norepinephrine and acetylcholine on the heart. Explain the role of calcium in cardiac muscles contraction. Include the mechanism of its release into the cytosol and its return to the SR and extracellular fluids. Excuse me. All right. So first off, we need to understand what we mean by inotropic, lusotropic, and chronotropic. Inotropic relates to the force of the heart muscle contraction. Lusotropic is the relaxation phase of the heart muscle, and chronotropic affects the heart rate. So norepinephrine is one of our most known neurotransmitters. It's inside of the sympathetic nervous system, and that is going to enhance all three inotropic, lusotropic, and chronotropic actions through its interactions with the beta 1 adrenergic receptors on the cardiac cells. I wrote that one down specifically. So when norepinephrine binds to these receptors, it's going to activate the G protein coupled receptor pathway. And this activation leads to an increase in cyclic AMP, or our CAMP. And this is going to increase also our protein kinase alpha activity, or PKA activity. So inside of the cell, the PKA phosphorylates, and it's going to target several cells inside of the heart, including the L-type calcium channels and phospholambin. And all of those are crucial. They're very important for our inotropic and lusotropic effects. Phosphorylation of the L-type calcium channels will increase our calcium influx during the action potential, basically when the heart beats. More calcium means stronger contractions. So that's going to obviously be our inotropic effectors. Harder heartbeat. Boom. Larger action potential, more contraction, more blood pressure, more volume moving through the heart because we're doing that. It can also be damaging as well. And that can actually lead into a positive feedback loop if you're not careful. If there's too much of it, too much of the inotropic effectors, positive feedback loop, your heart can blow up, essentially. I think I read something about racehorses doing that. They pump them full of something. I can only imagine it might be an inotropic effector, or it could be chronotropic, where the heart is beating so fast it just can't keep up with itself. All right, so PK is also going to phosphorylate something else, which I struggle with this name, phospholambin, and that is going to regulate the sarcoplasmic reticulum calcium pump, or our SERCA. And when the phospholambin is phosphorylated, the SERCA activity is going to increase, and this is going to enhance calcium uptake or reuptake into the SR, and that's going to lead to faster relaxation of the heart. And that is our lusotropic effectors, where it relaxes faster. And when I say relax, I just mean following a contraction. It is faster to let go of that contraction, faster to go back to its resting state. All right, so for our chronotropic effect, our norepinephrine is going to increase the rate of depolarization in pacemaker cells in our SA node, and that is going to enhance the funny current, or the IF, and the inward calcium current as well. Both of those are going to be enhanced, and that's going to speed up our heart rate. All right, on the flip side, acetylcholine, so that was all about norepinephrine. This is now acetylcholine, is going to be released by the parasympathetic nervous system, our eat and relax, I believe, if I'm remembering exam 1 correctly. The relaxing one. All right, so Acetylcholine is going to be released by our parasympathetic nervous system, and this is going to exert negative chronotropic and inotropic effects primarily through muscarinic receptors, or our M2 receptors specifically. So binding that acetylcholine to the M2 receptors will activate a different G protein pathway, and that will lead to a decrease in CAMP levels and reduced pKa activity. So what this means with that lower CAMP levels means that there's going to be less activation of our L-type calcium channels, and because of that, reduced calcium entry into the cell, meaning weaker contractions or no action potential whatsoever. And that is a negative inotropic effect where the heart beats lighter and softer each time, maybe not even getting its full action potential. In our pacemaker cells, in our SA node, the acetylcholine is going to increase potassium permeability, and it's going to decrease the funny current, slowing the heart rate, and that's going to be negative chronotropic effect. Simple. All right, so our calcium ion, let me go back to our question before we move on, make sure I got all of that. Calcium in cardiac muscle contraction. All right, that is our next section in here. All right, so an action potential in a cardiac muscle cell will trigger the opening of our L-type calcium channels in the cell membrane, and that's going to let calcium ions flow into our cytosol, giving us essentially our action potential because of that. This initial influx of the calcium will actually trigger the release of more calcium from the sarcoplasmic reticulum through ryanodine. I struggle with some of this vocabulary. Ryanodine receptors. And this is called calcium-induced calcium release. So you put more calcium in, you get more calcium released. Womp womp. So this surge of calcium will actually bind to our troponin, and that's going to cause a conformational change that will move the tropomyosin away from the actin's binding sites. And that will allow myosin to bind to actin and initiate contraction, just like that. So for our relaxation, the calcium has to be removed from the cytosol. How do we do that? Well, the Serca pumps will actively transport the calcium back into the sarcoplasmic reticulum, and then the sodium-calcium exchanger, or a sodium-calcium pump, and our plasma membrane calcium ATPase, or PMCA, got that from the book, will help extrude calcium from the cell. So with those two things, we can remove the calcium, therefore releasing less calcium into our heart cells. All right, let's make sure I got everything. Include the mechanism of its release into the cytosol. It's returned to the SR and extracellular fluids. All right, that was it. I believe that is everything for question 3 of this accursed exam. See you later.